Hello everyone, and welcome back our class. Now we will study chapter 2, the first law of thermodynamics. The first section will study the energy conversion law. Energy conversion law includes two laws. The first law tells us the energy can neither be created nor destroyed. The total quantity is unchangeable in process. Here is the first law. It tells us the numerical relationship between different kinds of energy. The second law tells us there will be not only numerical relationship with different kinds of energy, but also quality relation between different kinds of energy. Here is the essence of thermodynamics law. The essence of first law. 100 years ago, after steam engine being invented, many scientists wanted to know the work and heat, how to change each other, and their numerical relationship. What is the numerical relationship? The first famous experiment was done by George Thomson. Here is the picture is their system, their experiment system. It's very simple, very simple. Here is a weight. Here in the tank there is a steerer. The weight down or upward movement give some steerer to the fluid, but the friction, the temperature may be increase. So there is some temperature meter. George Thomson experiment demonstrates. We can do some explanation about George Thomson experiment. In the process, the total quantity of work and heat keeps constant. After the experiment, George and Thomson found in the process, the total quantity of the work and heat always keep constant. We can do some calculation. Input work is mgh, just is the weight work. And obtained the heat is Qm equals m times the temperature difference. In that day, there is no specific capacity. So just is m dot temperature difference. He found if we use work divide the Q equals 0, always is constant. So he found equivalent weight between the heat and the work always is constant. So he finds work and heat always is constant. He finds the energy conversion law. So the essence of the first law is energy conversion law. It can be described as in any thermal process, work and heat can be changed each other, but the total quantity keeps conservation. So here is the first law. The essence is energy conservation. Second, the expression of the first law and internal energy. For closed system, for example, here is the piston. If outside give some thermal energy dq to the piston, in the piston the gas expands, so can provide some work for us to outside. Is dW. When a system undergoes a thermodynamic cycle, then the net heat supplied to the system from its surroundings minus the net work output from the system to its surroundings must equal 0. Just to say, all of the Q from outside to the system and do some work, the net work to the outside must be same. Energy cannot be created, cannot be destroyed. So in the system, in a cycle, in PV diagram, we can find outside give this system the heat energy must equals the outside equals the system give the work to the outside. So sigma Q minus sigma W equals 0. So in this case, we can find another very important concept. Last page we have learned in one cycle, all of the Q into the system must equals all of the work from the system to the outside. It's same. There is no difference. However, for a small process, very small process, is not cycle. Small process, maybe delta Q and delta W is not same. There is some difference. So we give an equation to calculate the difference minus delta W. du equals delta Q minus delta W. Here, U can be called internal energy. Means some energy storage in the system. Because delta Q and delta W is not the same. So the difference storage in the system. Here we have to discuss the properties of the internal energy. So here, firstly, we say the internal energy is a properties, is a parameters, state parameters. Internal energy includes internal kinetic energy, internal potential energy. Internal kinetic energy only related to the temperature. So it is a function of T. Internal potential energy only related to internal molecule distance, only relation to the distance. So it is a function of D. So therefore, U equals U. U is a function of T and V. For ideal gas, maybe only relation to the temperature, no relation to the volume. Because ideal gas, we think the molecules, between the molecules, there is no force. Internal energy, the unit is kilojoule or joule. So most cases we use the kilojoules. The basic unit is joule. Internal energy is a state parameter, only relation to the state, no relation to the process. Is very special. Expression of first law. When after studying the internal concept, so we can give an expression of first law. For closed system, conservation law of energy can be written as delta Q equals du and delta W. It means if you give some energy to the system, part of the some energy become the internal energy. Part of the some energy become work. For example, here is a piston. Piston is a system. If outside give some dQ, some energy to the system, part of the some energy become internal energy storage in the system. Some of the some energy become work. So delta W and delta Q is work and heat in a small process. So energy, the first law, we can give a statement. The heat supplied to the system minus work output from the system equals internal energy in the system. A piston is a typical closed system, so most cases we use a piston to discuss the characteristic of a system. Here also is a piston. The area, the piston area is A, square is A. Move the distance is dx. We know from the first law, dq equals dw and du. If the process is reversible process, so in this case, we know the expansion work is P dot A dot dx just is PdV. So if the process is reversible process, we can obtain the first law by dq equals du and PdV. Here is the first law, the function. If the process is very big, so in this case, we can use this equation to calculate. Give system the thermodynamics, the thermal energy Q equals the internal energy difference and the integration PdV. Here is this equation. All of them we can use to express the first law. But in this function, for any condition, this function only for reversible process. This equation also only for reversible process. The energy equation of a closed system. For an infinitely small process, if the process is very small, for any condition we can use this equation to calculate delta Q equals du plus delta W. For a reversible process, dq equals du plus PdV. For limited process, Q equals delta U plus integration PdV. Thank you very much.